Sweet. Okay, here we go. I'm just going to prove something to you, Dylan. If you're still there. See? Not some beer thing. All right. What? I didn't know you followed me, J. Cole. When did this happen? Was it? Oh, it was when it must have been right. Oh, it was right before Dylan raided me. You know, I'm very sorry. That is disappointing, for sure. Thank you. Thank you for the follow. Justine, I remembered your name. from watching. I know. I've got a lot of those. The older you get, the more excuses you come up with. This is going to be just an ASMR stream where I just sip on my drink and talk in my ASMR voice. That wasn't very good. I've got a pretty good one when I'm reading. I have a hard time actually duplicating tone over different days. That's autism for you. All right. Let's just post that we're streaming and we can get started. Hope everyone's doing well. It sounds so much better with my MacBook Pro mic. I don't know about that. I mean, not at least not with my MacBook Pro. Maybe the silicone Macs have just done something magical. But I have this Mac. The mic on this thing is a piece of crap. I mean, it's not the worst thing, but it's not great. And my computer sounds like a freaking jet engine when I do anything. Like opening OBS, the fans go to like high speed. If I didn't filter them out, they would be audible. It's pretty crazy. What is happening? That is a good question. Working on an iterator Embol for our binary search tree in Rust today. That's what we're doing. Well, if you're still there, Justine, I am honored that you came back, even if it was just to shame me for not thanking you. Okay, we did that. As usual, being an old man on the internet, nobody laughs at my jokes, but I thought this was pretty funny. I thought it was a pretty good one. Oh, starting soon is kind of screwing everything up, isn't it? There we go. I thought that was pretty good. Guess I'm alone. It's fine. I'm used to it. I'm used to being the one that laughs at my own jokes the hardest. Okay. Let's switch over to code, shall we? Okay. Awesome. Here we go. Iterator. Okay. Oh yeah, I can just do this. That makes more sense. I always forget. I think I have to do a type item. And then of course I actually have to define my we'll just call it T for now. And then oh yeah, LSP can do this one for me too. That's slow. It's slow as heck. All right, there's next. Okay, beautiful. All right, and we'll just start with the to-do iterator. How about that? Now we actually have to define our iterator type. Hey Allison, how you doing? Thanks for hanging out. I had like a good tweet that I didn't do, but it was brewing in my head. Huh. See Dylan, that's how you do it. That's how you do it right there. Allison knows. What was my obviously excellent tweet? I think Dylan already left. He just came in, said first, and he left. Classic. Yeah, no, just mess with you. There you go. You're in the background. No, I feel you. I know you're probably working. Most people are still working at this time, in the US anyway, right? I had a good tweet about TwitchCon that was something along the lines of like managers not understanding what this huge Monday productivity increase was about, and it's just because all the Twitch streamers are not streaming. I know technically it ended yesterday, but still, that was my idea. It's still it needed some work, so I just left that one. Let that one be. Okay, awesome. So we're working on our iterator. I actually started recording. Good job, me. Yeah, that's all good. Okay. So let's think about this. Maybe I should look at my ring buffer implementation, even though it's very different, just to like refresh my memory on how these iterator implementations go. It's probably a good idea. Right. I used a current front, current back for double-ended, and a ring buffer. Okay. So we're not going to do a double-ended for binary search tree. It doesn't make a hell of a lot of sense. I mean, you could do it, but it would be annoying. And I don't know why somebody would want that. I mean, I guess to iterate over the elements in reverse order. I mean, I don't know. I think you should just turn it into a vec at that point if that's what you really want to do. Which is what we're going to give you the option to do here. So what is it that we want to actually iterate over? We're going to have a node, and we essentially are just going to have the current node, but we need yeah, So we would have current and current parent. And if parent is none, then we know that we're at our root. Okay, we can start there. So if we say parent option node, we'll probably need like a box node or something nicer than option node. Oh, right, before we could just use indexes because we were using contiguous memory. Are we gonna want a yeah, it might work. Let's find out. Excuse me. Why is my indentation off? Struct BST iterator over T. This looks fine. Parent option box. Oh my god. I hit a number. I'm really good at that. What's the vim command to go to last change? I keep wondering and then I keep forgetting to look it up. Let's see. So far ChatGPT has kind of sucked with telling me how to use vim. Alright. Let's see. How do I go to last change and then to go to the last change, press G followed by semicolon. Okay. Let's see if that works. G semicolon. Hey, look at that. And I can keep going back? Ooh, wait, the G comma didn't work. If you want to go to the next change, what does the next change mean in this case? No later change info? That doesn't make sense. But see, this is weird. There's something wrong with the whole Emacs evil mode thing. Oh well, G colon is really all I cared about. Okay. Let's see. So why is this still off? What am I missing? Oh, it's just that parent wasn't indented correctly. Okay. I think this would actually work if we just keep track of parent and we keep track of current, then we should know where we're at. Okay. I don't see a particular problem with this. Compiler seems fine with it. Let's go up and create our iter function. Let's see, pub function iter, and I always forget what the right way to do this is. I wonder if LSP can tell me. Is it really? Oh, there's no match. It said that right away. Okay, no match. Okay. Let's see. Let's go to ring buffer and we'll just search for iter. Like that. takes a reference to self, right? Because it's a non-consuming deal. Okay. That should work. So we take a self and we return a BST iterator over T. Awesome. Anybody have big fall plans? I like getting out in the fall more than other times of the year usually. You know, I mean, in Tennessee we have like kind of real seasons, not quite, but kind of. And fall and spring are definitely the nicest. I think we might go camping in the next couple weeks, just like a single night camping trip somewhere close by. There's like a million places to go within an hour drive. Because we're really close to the Smoky Mountains and all that stuff. Okay, so we're just going to create a BST iterator. Did I actually do an impl block on my ring buffer? No, I just did it this way. That makes more sense. Yeah, I like that better. So it's going to start with parent being none because our current is going to be... Oh, that's really interesting. No, that's wrong. Hold on. How do I want to do this? Do I want to create the initial traversal here? I didn't really think about this before. Do I want to create the initial traversal here? Or do I want to so basically the idea, like the right way to iterate over a binary search tree, we can define that real quick, is you'd want an in-order traversal, which means we would start at our deepest left and we'd say 1, 4, 4, 5, 6, 8, 9, 17, 800, 900, right? And so basically what I'm not sure of is I can either define, I can define the current here, but I would still actually need to know how to keep track of the parent at each level. Ooh, that is confusing. How do we do that? We could just kind of use a stack. That's not a bad choice. So let me think. If we just use a vec in our struct, we could keep track of where we're at. And basically each level that we go down, we would push there and then pop off. Yeah, that sounds right. We basically are going to use a stack in order to iterate over this the right way. Yeah, that makes sense to me. Okay. So maybe we don't want parent. We want, like, we could call it parent. I don't know. What's the right way to say this? I guess we could say stack. Okay, this is gonna be interesting. Let's start. I think either way, I would rather not create something here. How do I want to represent the initial state? I guess I could represent the initial state by just having the root there. Oh, that is interesting. Okay. Okay. I'm gonna try this. I don't know if I'm gonna like it, but we'll try it. I'm gonna start with current as root, and then parent, we'll just do vec new. We could have like actually kept track of a length, and then we would have like our initial allocation of the vec, but that doesn't actually make sense because actually at any time we're not going to have our full number. But if we kept track of our height, actually our parent vec should never be greater than our height, and that actually would have been reasonable if we tried to keep track of our height. That's just like an optimization detail, but it could be cool because, you know, how many levels we go down, which is what's going to go into these parent vec, this parent vec. I don't actually know. I think I just want to call it the stack because I just, instead of this parent malarkey, I like that better. So let's do this, and this is just going to be a vec of node t. Okay, too many of those. Did not mean to do that, but that's fine. Really? Oh, that's what it was. I did a command instead of just the thing. Okay, what? I thought I had too many of those. Oh, it's not going to be a vec of node t, though. It's going to be a vec of box node t. Okay, so that's enough. Expected, colon, colon, found, comma? Oh my god. I'm being dumb. I'm being dumb. Don't mind me. There we go. And I guess our current will always have something. Yeah. Okay. So let's go ahead and take off the optional from this. Our current will always have a value, and then this is probably giving me yeah, this. That's interesting. So let me think about this for a second. If this is none, oh, okay. We have to represent an empty binary search tree. And current doesn't really do that unless it's optional. So I guess that can be our optional. It's a little annoying to have that. I mean, I could do it a different way, but I guess I'm not going to. So, just kidding. Let's make that optional again. Okay. Now what are you mad about? Okay, moving. Yeah, I figured I would get this part. One second. Partner message. Okay, all set. So we have an option box node T. I could do a couple things. I could rewrap this, or like I've seen other people do, is they essentially create a new type for the node iterator, like how what you're going to store the node as, differently than the way that you store, differently than the actual node type, and you basically kind of, so that you don't have this thing where you have a box and all this kind of stuff. Now this isn't going to live as long as I want it to. Let's just reference our ring buffer real quick, because I'm spacing if I had this problem. I didn't have this problem because, again, contiguous memory, I could just store offsets, stuff like that, and I didn't have to worry about all this. So this is similar to what we would have encountered if we actually did our iterator implementation for our linked list, and we didn't. So that's okay. we're going straight into a harder example. Not a lot harder, but a little bit harder. Okay, so I think what we want is to probably create some new information out of current, out of self-taught root. But let me think. It's either that, or I just do a literal rewrap of self-taught root, which I could do. Okay, let's just try this. And then takes a n, and we could just say sum n. Does that work? It doesn't because of this, which is fine. And then takes, and then doesn't consume though, right? Takes the option. What if we did, whoops, as ref? But then I think we're gonna be back into a lifetime problem, but maybe not. Okay, expected enum option box binary search tree node T got an option and box binary search tree node T. That actually should be fine, assuming that we can make it work. But the problem then is that I have lifetime parameters. We'll just keep going down this path for now. We'll keep going down this path. Whoops. Now we're basically guaranteed that the lifetime of our iterator will be as long as our lifetime of self. So I think the way I would specify that is like this. Maybe not though. Let's see. Oh, a use of undeclared lifetime. Yeah. So I have to do that. Right. I thought. That not how I do it? Can't leak private type. Okay. I don't remember what that error means. Let's build it in terminal. Yeah, I'm just silly. It's a classic. I didn't make the iterator public. Okay. It compiles with our lifetime annotations. That wasn't so bad. We can handle that. Yeah. This is good. This might work. Might being the operative word. Okay. Oh, Slack messages. What are these about? 1 second. Work. Yeah, just some infrastructure messages. Okay. I don't usually have to actually do anything about infrastructure stuff, but I do have to make sure the people that do infrastructure stuff are doing infrastructure stuff. Doesn't that make sense? Okay, let's just... Awesome, thanks. We'll check this out and let you know. Okay. Think I caught up on everything. Yep, looks good. Whoa, sorry about that. Hit my pop filter and made everything pop. Okay, I think we're ready. We're back. All right, so I just have to run this so this red isn't staring me in the face. Oh, that's nice. It's a nice compile. Okay, so we have our builds. We're good there. We have our stack. We have our current. Yeah, I don't hate this so far. Let's see what it's like to iterate over it. We'll find out. Let's just start up here. And we're going to start with our base case of if, right, if current, oh, actually, we can just do this. If sum in equals, I meant if let, oh no, what did I hit? I hit the wrong button. I'm having all sorts of problems today with hitting the wrong button. Okay. If let sum in equals self dot current cephle dot current self dot current dot take. We can just take that. Then do this. Else return none. Okay. Now we'll go up here, wrong way. Paste that in. And see if we have any errors. Okay, so far so good. So we're gonna take our current and, ooh, yeah, I think this will actually be pretty nice. Okay. If, so there's gonna be 3 things we're gonna do on our current. So let's start with a match and see how we like it. So let's say match in, and we know, yeah, we have a box of node. Okay. I'm trying to remember how this works. Oh, right. I think how I can do this is say left sum left. And I think I can do this and then say if there is something in left, then we should set current to that reference. So then we would say self.current equals sum L. I can't remember if this is the right way to do this, but we'll find out, won't we? Okay, let's get rid of this. And then we'll just leave a base case and return none and see what our actual errors are. Lots of them, lots of errors. Match on in. Expected pattern found that. Yeah, there's something I'm missing on how to do this. What am I missing? Do I have to like specify the type? I always forget. Matching on struct fields. I literally just looked this up and I forget already. Oh well. That's how I do. I don't think I did this. Pattern matching on Rust structs. It's still here. It's still here. Person, name, age, if name equals Alice and age is 18. No, but there's like there's a more complicated example. Okay, I'll just try asking in this chat. Can I pattern match on the value of the field of the struct? No, I meant in the same match statement. Oh, match person, person name a, no, it's a nested match. I don't want a nested match. Okay, so I'm guessing I just can't do that, which is fine. So the other option I have, if I want to make it a single match statement, which I'm pretty sure I do, and to make it nice, I should be able to say match n dot left n dot right. Okay, and then it'll just be a simple tuple destructuring well okay, and instead of dot dot, I think it's more idiomatic to just do this. Looks like dot dot was valid syntax, which I didn't expect. Okay, hold on. More messages. Busy message day, I guess. Okay, this is literally what I just said. Okay, there's the replies. Slack. Slack is kind of crappy sometimes. Okay. And I'm back. And let's see what we're doing wrong. Mismatched types. Expected enum option T. Oh yeah. That's a good point. Yeah, because this isn't what I actually want to return. Sorry, I just wasn't done. Sorry, editor. Okay. Self.current equals sum L. And then oh, that's interesting. Okay, I think I'm seeing why this structure may not actually work. I think what I actually need is essentially an iterator on my node type in order to encapsulate the logic of getting the next node. Okay. Interesting. Self.current equals sum L. See, that's fine, but that's not actually what's going to get my next type. Like get the next value that this iterator should be producing. Here I'm actually iterating down and figuring that out. Okay, so I think what I want is, yeah, just give me a second. I think I need a node editor. It's either that or I write a function to take whatever our current is and then go through and do a bunch of craziness, but I think that would be mostly frustrating. Okay, so let's just write out some kind of pseudocode. To see if what we're thinking about actually makes sense. I don't know that it does. Some value of type T. What? Oh, consider borrowing here. Yeah. you just mean like this. But then you have a borrow checker constraint. Yeah, and then I'd have to annotate those lifetimes. Yeah, this would be annoying. There's got to be something nicer than this. Okay, we'll just let that be. I'll comment this out so we don't have any errors. Okay. Why didn't it show me that first? I swear it did not. Okay. I'm interested to see what happens. This should actually give me borrow checker errors, I would think. Okay, so why does this work? Oh, right, because it can figure out the lifetime from self. That's why it's working. Hey, Nightshade dude, how's it going? Good morning, where you are. You must be a Pacific time type of person. Over on the Eastern time zone. Oh, it's 12:08. Classic mountain time when I like mountain time. What's funny is I feel like mountain time, I used to feel like mountain time was just like the rarest for at least, you know, whatever, US based work. And then it just seems like every single person that's like, oh yeah, I'm on mountain time. It's like, what happened? What happened in the last few years? Because I used to be on mountain time until we moved back to Tennessee like 3 years ago. But yeah, I think that's really what it is. Yeah, now that I think about it. Because, what is it? Swalker, he's on mountain time because he moved from California to Idaho. And yeah, I mean, I left New Mexico when a bunch of people were moving there. If I would have owned my house, I probably would have made some good money, but that's okay. I didn't know him. Yeah, traffic's so bad now. I mean, Knoxville traffic is insane. It just like, you have all these small places where all these people have flocked to, and like the infrastructure is just crumbling underneath how many people are there. Like you could get, without traffic, I can get from where I am to like downtown in like 10 to 15 minutes. Hey, David MinQ or Mink, you can tell me how you do that one if you want. Thanks for the follow. Yeah, thanks. I got distracted by your name and forgot to thank you. Yeah, seriously, it's crazy. What was I saying? Oh yeah, but on like a normal day, unless you go at like the best time possible, which is usually like 2 p.m., like you're talking 45 minutes to go 15 minutes away. You know, it's annoying as hell, and people suck at driving so bad that there's an accident literally every day, like real close to the exit I live off of on the highway. So it's pretty dumb, but I can't complain too much. I work at home. I mostly just get to hang out at home, and I don't like going places for the most part, so it works out. Yeah, exactly. I mean, the thing is, in Tennessee, people are fucking going 20 miles per hour on the 65 mile per hour highway, like on a normal day with no traffic. And I'm like, what are you guys doing? I learned to drive in Southern California, and so like I mean, it's an exaggeration, but literally 45 to 55 on a 65 mile per hour highway is not unheard of in both lanes. Like, you got 2 lanes and you're all going between 45 and 55. And you're just like, what are you guys doing? Yeah. Learning to drive in Southern California, it's hard for my brain to compute. Oh, that sucks, Dylan. I'm sorry, dude. I haven't got a ticket in quite a while, which, yeah, you can usually get that, like, get that reduced pretty good. I had a really bad one in Atlanta like 10 years ago. That was bullshit. But yeah, I had a really bad one, and you know, hired a lawyer because it was so bad, to get it reduced. And I still had to go to traffic school and stuff. That sucks. Yeah, I don't remember like the details, but like the judge wanted to put me in jail for a night for speeding. For speeding, he wanted to lock me in a jail cell for speeding. Yeah. Yeah, mine was 65 and no, it was probably 60 in a 30, and that was because this is miles per hour for the international folks. It was 60 and a 30, but it's because it was a fucking freeway exit. So we exited the freeway, like in basically downtown Atlanta, going 70 miles per hour, and I was somehow supposed to slow down 40 miles an hour with all of these cars around me, and it was a short exit, like super fast, and there was a cop car literally on this exit, like, because obviously they knew this was a speed trap. And so it wasn't like I was ripping through a neighborhood here. Like, this was just, and then so when the judge said that, thankfully I wasn't there, because I probably would have scoffed at him. I would have been just like, you're an actual moron. You're so stupid. But that is the American justice system. It's really, really good. Yeah, fun times. That sucks, dude. I'm sorry. But yeah, hopefully. Yeah, exactly. Like, you get a chance to slow down. But like, if you're going to like sit there with a speed thing, whatever they call them, to like at the exit before people have like there's a signal at the end of the exit. Do you think I'm just gonna blow through the signal at 60 miles an hour? Like I don't know. It was the craziest thing. It still bothers me 10 years later. But yeah, yeah, those are just classic, Dylan. It's such bullshit. It's just absolute bullshit. And I mean, in general, the judges will see these things all the time, like especially that sort of thing. They'll know exactly where it was that it happened, all those things. And with a reasonable lawyer, just even any lawyer, you can pretty much get it down. And sometimes just showing up by yourself, you can get it down to just like a typical speeding ticket with traffic school. But you know, I'm hopefully, right? I hope so. Traffic policing is some of the dumbest thing that they do around here. The way they do it is just absolutely asinine. Anyway, let's see. Where were we before we went off on the problems with American traffic laws? If self.root, that is no, we're not there. We were talking about, oh yeah, how we wanted to do this whole node thing. So I wanted to write it out in like pseudocode, or at least some notes, so I could see if this makes any sense. I got like fired up over the whole traffic thing, and then sometimes my brain takes a minute to actually like calm down. It's so dumb. It's so dumb that I get so triggered over that stuff. I get so mad. Oh man. Craziness. Okay. Here we go. Right. So what we need to do is, let's say we had a node iter, and then our BST iterator just had a node. Like, instead of all of this, they could just have like a node iter, which is node iter field. Okay. And then when we call BST next, BSTI, oh dear, BSTI.next, it would call node iter.next. Node iter.next would keep going through until it found the right thing. I don't like it. Okay, let me think about this. No, I don't like this. I don't like this. Okay. It's too many layers of indirection. It's too annoying. Okay. So how do we go from I started this, I have my root node, to I get the actual next value that I can send out on my iterator? We could have a node method. Interesting. Yeah, we could have a node method that does that. And what would that node method be? That node method. Oh, okay. Okay, we're getting there. We're getting there. Okay. Nope. I don't know. I'm having a hard time figuring it out. Okay, let's just write out what we need to do. We have root. We need to go to leftmost node. And we need to keep track of every node we visit. Okay, this makes sense. I mean, essentially this is a like an in-order traversal, right? And how would I code an in-order traversal? If I was not thinking through all of these things, I could say just traverse down left or traverse down right, and then it would keep kind of popping off the stack just from a recursive standpoint. Okay, I can visualize that. But in this case, I need to keep track of it, and that's the part that I'm having a hard time with. I need to keep track of that stack kind of manually. So I think that's where current doesn't make a hell of a lot of sense. Because I also have to like know when I visited those nodes. Maybe that would help me, is just writing this out as a function without thinking about it in the iterator thing. And if I just write it out as a function, I might be able to like process how it would work. Let's just do that real quick. So if we just said function, we'll just call it, and we'll just call it IO traversal, or in order traversal. And we have our output type, which is like an array, or a vec in this case, be easier. So we have our BST, which is a binary search tree. And then we have our output type, which is a vec of t. Okay. And we have to declare this as mutable. That's the wrong way to do it, isn't it? Is it? Gosh, I don't do this. It's just, is it before the argument? These are like the classic like Rust things that I'm just like dumb about. Yeah, that must be it. Okay. That's the wrong place to put it. In a function. Okay. Try that again. There we go. That looks fine. And this is just gonna say it doesn't need to be mutable because you haven't done anything. Yeah, that's all good. Okay. So our in order traversal is gonna start with our yeah, let's make this an and as well. To make that simpler. Okay. So let's start similar to this. We're gonna say if let sum n equals bst dot root, and we can say this, then we do something. Just return none for now, else. Actually, we don't need an else. We can just, because we're just returning our output. Okay. You already don't like me. Oh, because I didn't define a return type. That also might help. Back T. And this isn't right, of course. We don't really have to do anything here. Okay. We're in a good place. So if let sum n equals bst.root, then we do something. Otherwise, we would just return our empty output. So let's create another vec, which is going to be our stack. Let stack equals vec node t. I think it's gonna have to be a box though. Vec box node t. New. Okay. If let sum in bst dot root. Yes. And then we're going to say if n dot left dot is sum, just to make this simple. Else if n dot right dot is sum, then we do this. Else nothing. Because that means that there's no, oh right, but if there's none, oh that's right, nope. So that's part of the whole in order. We can probably get rid of some of that because we can check for it in our function. Oh yeah, we might not actually even need that stack, right? We don't actually need this if we do it this way. Let's just create our current place, which is then just going to say function node traversal t. This is going to take an n, which is going to be a box node t, and it's going to take the output, which is a vec t. And then we're going to say it returns our output. Okay. Thinking through this. So we have a node. So it's just a matter of if we want to check that it's optional here or if we want to do it somewhere else. I guess we might as well just check that it's optional somewhere else for now, and we'll see if we want to do it differently in the future. And that will kind of make this whole thing just work. But that means we can go here, and all of this can move up. Okay. And then this just becomes something that doesn't need to be this complicated, but that's okay. Node traversal. And output. And I guess we can just do this. Why don't you like this? You have a box node T. You have output. Oh, it's just because I'm not actually returning anything yet. We'll just return output down here. Value moved here. Oh yeah, that makes sense. Just off a call with the traffic attorney. Yeah, good deal. Yeah. That can also help, especially if they're regional, because they'll kind of know, yeah, you're fucked or not, you know? Yeah, awesome. That's good news, dude. Happy to hear that. So to not have to deal with this, what I could actually do, since this is technically moving it, is we'll just put this in an else branch. And then go here. And then that should be happy. Okay, cool. Does not need to be mutable, yeah, because I haven't actually mutated it at all. The farmer assistant DA. Let me go talk to my former boss, and we shouldn't have a problem. Oh man, that's funny, dude. So this is more like how I would do this in order traversal, like in a different language that's not Rust. In general, I mean, this will work in Rust, but obviously we want to do something different for Iterator. But I need to like have a basic understanding of the problem instead of trying to do like 5 steps at the same time. So that's why I'm doing it this way, in case anybody's wondering. So if n.left.isSum, then we're actually just going to call node traversal with n, and oh yeah, we just want a mutable reference to output. I just realized. That's where I messed up here. Let's say and mute output. And then this is going to take an and mute. And this is going to take an and mute. Now, if it's already and mute there, no, that should just work then. I already have, no, yeah, I'm being dumb. I should be able to just pass this around like this, I think. But we'll find out. Yeah, I mean, I know there's problems here because now I'm like doing all this stuff, and I probably can't just like do ref it at the end and say, hey, return return the thing that I want you to return. So what we have to do is say and mute vec t there. Oh, move and mute to the type. Wait. I'm confused. Let's build this so I know what's happening. Expected vec t found. Yeah. Try using a conversion method to vec. No, I'm pretty sure that's not how that's going to work. I think I should be able to say to owned, and that might work. Nope, doesn't like that either. Oh, fucking borrow checker. Sometimes I just want something simple, and it doesn't like it being simple. Let me think. If we have a mutable reference here. Okay. Let's worry about one problem at a time. Which problem do I want to worry about? I think I want to worry about the node traversal problem, not the other one. So let's just return output. Nice. Typos. Okay. All good. All good there. Now let's see what our errors are above. Okay. Where are we at? And mute output expected due to this. Expected vec t found and mute da da da. Okay. Did I just put and mute on the wrong side? Yeah, that's what I did. It was just supposed to be part of the type. I was just being dumb, I guess. Okay. So now we should have less problems. Yeah, I could do this. This function's return type contains a borrowed value, but the signature does not say whether it is borrowed from in or output. Yeah. So then you have to introduce a named lifetime parameter, which is annoying, and we're getting closer to being just as complicated as we started with, but that's okay. It just doesn't know which one of these it's supposed to get that lifetime from. Okay. Yay. And we'll probably have the same, right? Since below we are saying we're returning we're not returning references. We won't have to specify the lifetime there, which is helpful. But here we do. Okay, so node traversal in output, it's going to continue down the left until there is no left. If there is no left, all we want to do is do an output dot push oh, vec's kind of an annoying. Is this fine? Give me a sec. But it doesn't really matter exactly what I'm using as much as... Really? Okay. God, that was slow. Appends an element to the back of a collection. Oh, so that does do back. Why was I thinking that it's not back? Oh, because it just pops off the back as well. That's fine. I don't need to worry about popping. Okay. I was forgetting what's happening. Okay. Hey, Frito. Or maybe a different pronunciation of that. But yeah, thanks for the follow. Thanks for hanging out. Glad to have you here. We're working on our little in order traversal. It is Frito. Nice. Love it. Okay, so all we need to do is push our value. Obviously, that's a little annoying in Rust because we would want ideally to kind of like own our value versus like have a reference to our value. But let's just see what makes sense here. I think for the sake of this example, let's just define T as clone. Even though we'll do something different. Oh my god, if I knew how to type. In our iterator. And this will just make it so that down here I can just say n.value.clone. Because otherwise it's going to say I'm moving the value out of n, or we have to specify lifetimes. And I just don't feel like specifying the lifetime right now. Okay. Might help if we added a semicolon. Okay. And then if n.write.isSum, then we just do a node traversal down there. And then finally, we just return our output. That looks pretty good. Seems to be compiling. Let's see what happens here. I figured we would have some problems, which is okay. We just have to figure out how to fix them. Isn't that surprising? Okay, not sure what just happened there. Let's try this again. Still doesn't know what's happening. Okay. Nope, I was just impatient. That's surprising. Slow as fuck. Yeah, I hope you're doing well today, Frito. Okay. So the thing is, I'm getting that mutable vector. Oh yeah, I'm not moving it anymore. So we can actually just go back to what we had before. This will be nice. This will be nice. Actually, it will be that. There we go. Not so bad. Oh man, come on. I really thought we had it. Oh yeah, T is not satisfied for clone, yeah. That I knew was going to come. Hey, not so bad. Okay, let's just test this out real quick. Make sure in-order traversal works. So in-order traversal is like a very classic tree concept for those that don't know. In case you were not here when we went over it, here's our little binary tree. Our in-order tree traversal is going to be starting with left, the very left, going up, and then going down right. So in this case, an in-order traversal would give us 1, 4, 4, 5, 6, 8, 9, 17, 800, 900, right? That's how that works. So we can try this out. Let's just do a new test. Function IO traversal works. Let BST equals binary search tree. Let's just do iSize new, and I guess we might as well do uSize because we should just do our tree exactly like it is because that way we know what's up. Okay, so what does that mean? That mean, oh crap, I forgot, I can't move Emacs. Annoying the way I have my OBS set up. Okay, so that means I just need to move this browser for a second. Okay, that'll be fine. And here we are. bst.insert 9 and oh yeah, might help if I declared mute. Just maybe. Just maybe. I'm good at forgetting that one. Okay, so then we're gonna go 5, and then we're gonna go 4, and then we're gonna go 1, and then we're gonna go 4, and then we're gonna go 6. Whoops. And then 8 and 17. Now, of course, what order you that's very me. What order you insert these in does matter. Okay, so that's 900 and then 800. Okay, so we have all that. And then if our in-order traversal works and we output it into a vec, we should see what we want. A second, almost there. Okay, let v equals IO traversal BST, and this just takes an and BST, and then I thought of something that I wanted to fix about my other function, and that's that we don't need to let them pass in the mutable vec. Like, we can just create it. It'll be nicer. Let v equals vec new, and that has to be mutable. Oh yeah, right. Let's declare it as mutable, and then we can get rid of this whole thing. Almost. Okay. And then output just becomes our V, and this becomes our V. Everybody happy? Yes. Nice. Okay. So that's our V, and let's just debug print our V. And we can also do an assert EQ on what this should be. Oh no. Okay. Oh yeah. I know how to fix this now. All right. We can do this. This is an Emacs bug that I think it's due to my Rust toolchain. But if we just go here, and it only affects the one frame. So if I just get rid of that frame, I'm back in action. Okay, looks good. All right. So what should we see? We should see 1, 4, 4, 5, 6, 8, 9, 17, 900, 800. Nice try. 800, 900. Yeah, that looks good. Okay. So let's run our test here. Let's see. We're going to say cargo test IO traversal works. No capture. Test failed. Okay. No worries. What do you not like about my test? Overflowed its stack. Okay. Debug V. Interesting. Not what I expected. Okay. So obviously we have an infinite loop or something along those lines, so our base case isn't right. Let's think about how this works. So we start at our root node. We pass in node traversal to our root node. And we say, oh my God. I bet everybody saw that long before I did. N dot left dot unwrap. How about that? That's very silly. Okay. Very nice. Yay! In order traversal. Okay, so this is helpful because we know that in order traversal is actually working, and we know how in order traversal works. So that's nice to know. Now we have to I mean, if we wanted to be like really simple about it, we could require clone on T and then just like throw this in there in our iterator, but we should basically. Like we could just have like a vec underneath that we just turned this into, and then and then we have traversal. I mean, what we actually did just implement, I mean, we did require a T to be clone, but we actually just implemented from binary search for Vec. So that's kind of cool. We could actually even, to prove that, we could do this. And for now, let's just say T has to be clone. And we would say IO traversal and value and let's see, if that compiles. It does. How about it? So originally I was gonna say, like, let's just like implement Iterator in order to implement from binary search tree for Vec, but in this case we kind of just did it ourselves in this little function. Obviously it requires clone, but we could work on it not requiring clone. We could do that. So what we could do here is actually kind of the same thing, which is we could say, I meant to paste that. Vec from BST. And now we have our from trait, and let's see if that test works. And it does. Pretty sick. Okay. So we finished in order traversal. We have our from trait working. That is from BST to Vec, or for Vec, you could say. So that's kind of cool. Let's commit. I haven't committed in a while, actually. BST delete works. I haven't even committed since that happened. And from Vec implemented. So with the from Vec implemented, if T equals clone, we're kind of halfway there. Obviously, if we did a Vec from BST and then created an iter on that Vec, we would be okay. We could actually do this backwards in the sense of our iterator could just use this from Vec implementation, but it is not idiomatic in the sense that ideally your iterator is a zero cost, I mean, it's supposed to be a zero cost abstraction. Like it should be like a lazy sort of thing that when you call next, like when you create it, you haven't really done anything. When you call next, you're actually doing work. So that would be like the ugly thing of us using our Into Vec essentially behavior. Okay, so let's try to get clone off of those functions and see if we can figure that out. And if we can, then we're closer to how I'd want to do it for an actual iterator. Wrong one. Really? Okay. I forgot that I can't do the quick switch buffer when I'm in the cargo buffers. Okay. So let's start with taking clone off here. And that means we're gonna need a lifetime. So let's go ahead and name our a lifetime vec, which I could have done easier, but that's okay. Who wants to do things the easy way, right? There we go. Okay. And then we're going to want to make our T lifetime something else. Okay, so let me just think about this. Right, so that's the difference between... okay, so this would actually change... Okay, so when you do a from or an into, it consumes your underlying structure. And so I'm actually kind of like fucking with the different things that I need to do here. They're going to be almost identical, but one is going to be by reference and one is going to be the actual owned thing. So that's where this IO traversal thing here doesn't exactly work. So let me just think of how I would want to do this. Okay, we could make this more generic, like a true generic traversal, in the sense that instead of, I could just have it either have an, what am I trying to say? We could do something with each node as a function. That's probably the way that I could keep part of this without it being bad. Okay, good words, right? Really good words. I gotta commit, so we can always go back to what we had before. And I'm not exactly sure how I want to do this. So we'll see how this goes. For now, let's just go for feature parity between the two. As I give this thing a function instead of all this vec stuff. Oh, I don't know if this is going to work the way I want it to. Now that I'm thinking through it. If the traversal has a reference, that means that my nodes are going to have references. And if my nodes have references, that means my values are going to have a reference. And the only way I can get an owned value from a reft value is if I have clone. So maybe I do have to have... Yeah, I think I might actually need clone. Oh, right, I don't need clone because I'm consuming. But basically what I wanted was a single function that could take, either by reference or not, it would work in both cases, but I don't think that's actually possible. Yeah, I'm not seeing the possibility. I still want to do this. It doesn't change that I want to do this, but what am I thinking? Okay, so I'm still gonna have a reference there. Oh, that's right. So I wouldn't need clone if I don't have the reference. So I guess that's what we want to do. We're just going to say that we own this and that we don't, our output isn't our output, it is our transformation function, and our function is going to be something like, actually never had to do a function type on a function before. I've never created a higher order function, or at least I haven't in a while, in Rust. It's pretty funny. Wow, good times. All right, give me a second. I need to do a message check here. Looks good. Okay. I think I'm going to stand up. Okay. We're standing. Mic needs to be raised a little bit when I stand. All right, so our function is going to be a function that takes a node. I think I can just say it takes, let's just try this. I guess we'll just say box. It's fine. Box of node T. Chris Sean, thanks for the raid. Hey, how's it going? How is it going? Let's see. Oh, I have my zitter open right now on there. Here, we'll switch over to GitHub so we don't have to enjoy it. Yeah, thanks, man. I really appreciate it. I'll give you a shout out here. I don't think I even follow you, so I'll have to fix that. How's it going, Raiders? What have you guys been up to? Sounds like Chris probably had to go, but what did you guys do today in stream? I'm just checking out. Chris's Twitch real quick. Okay, cool. For some reason my internet is just like hella slow right now. So apologies for that. Okay, cool. So you guys are doing a bunch of learning. Looks like maybe some React stuff, that sort of thing. Different stacks, perhaps. Neat. Very cool. Well, hey, welcome. Glad to have you guys here. I'm MetaMe. I mostly stream Rust. I have been in the industry for the last 10 years. Let's see. I started mostly on front end. I got a job as a front end focused developer, working in JavaScript, of course, and all that good stuff. It's quickly transitioned into full stack, working with Java on the back end, and then we introduced TypeScript and all that stuff. It was 10 years ago, so TypeScript was fairly nascent, and kind of moved into a more, closer to a stack that you would see today. But, we didn't quite jump into React and all that stuff at the time. And then after that, I got a job about 5 years ago writing Clojure full-time. Clojure is kind of a niche language. It's hosted on the JVM, Java Virtual Machine, and I am now solely a backend developer using Clojure. Right now, we've been working on a bunch of data structures in Rust. Currently, we're working on a binary search tree, and I'm just working on a traversal algorithm for the binary search tree. We had one working, but I just want to make it a little bit better, a little bit more generic. Before it was just kind of like a single use case, and right now we're generalizing it so that I can kind of like pass in any function to this traversal and it will do something with each node in that binary search tree. So if you don't know what a binary search tree is, feel free to ask any questions about this. Totally fine if you don't know something. Let's see, where did I put my binary search tree? I stuck it somewhere. There it is. There's a binary search tree. But basically it's a binary tree, which means you have just 2 branches at every single node. And it is in order. And it is ordered by the left branch, everything on the left branch being less than the node, and everything on the right branch being more than or equal to the node. And so if we just have a basic traversal, an in-order traversal would go 1, 4, 4, 5, 6, 8, 9, 17, 800, 900. So yeah, that's how it works. Coder dyslexic. You're just inspiring developer, like an aspirational developer, like you're trying to get into the industry. Still trying to figure out the best path for me to take. Definitely thinking about just focusing on front end and then transitioning to back end so I can be full stack with my dyslexia. I feel that it might be more important to focus on one end at a time. I mean, people have different, like YMMV, right? Your mileage may vary. I mean, definitely focusing on, it all depends on how you learn, all that kind of stuff. I'd say in general, as a self-taught person, which I'm also a self-taught developer, if you're not like in school and stuff, I think it's kind of easier to break in on the front end. You might be able to break in full stack, like a JavaScript-y stack, but I personally think it's usually easier unless you're doing something like PHP, which I am less familiar with because that's not the path that I took. I essentially took the full stack JavaScript path but that was 10 years ago, and the market's changed a lot. So I can't, exactly say what makes the most sense for you. But yeah, totally. Well, welcome. Thanks for hanging out. We do get into some pretty we get into the weeds quite a bit. Get pretty crazy, pretty intense. But it's still fun, and it's always great to have people of different experience levels, so that you ask good questions, all that kind of stuff. It helps me explain things, because people who've been in the industry a long time, like, they might not know what a binary search tree is, but they're afraid to ask and all that kind of stuff. So, people that are learning can ask good questions, and we can all learn better together. The Hacks Flax, thanks for the follow. I appreciate it. So yeah, if that sounds like something you'd be interested in, let's do it. Data structures. We've done quite a bit in our data structure so far. I can show you guys real quick here. So we implemented an array list, which is a more generic term for like what you would use in JavaScript as an array. We then implemented a linked list, and a linked list is a node-based data structure. And I don't mean node as in Node.js, but I mean that each thing has a node and they're all linked together. So that's how that works. You essentially start with like a first node, and that points you to your next node, and so on and so on and so on. And then you have a doubly linked list, which we did, and where a linked list just points one way, you start at your head and you point all the way to your tail. A doubly linked list has both a head and a tail that we keep track of, and it points both ways. So we can go either side. And the reason that's useful is because we have easy access to both sides of our data structure. So if you want to add a value to the beginning, or you want to add a value to the end, and if you want to remove a value at the beginning or remove a value at the end, you have that constant time, quick access efficiency. And that's where doubly linked lists can shine. In a similar way, a ring buffer, which I'm not going to explain because it might be too complicated to explain as quickly as the other ones, but a ring buffer can also give you both head and tail access very quickly. It just does it in a different way than a linked list, because it actually uses a single block of memory, where a linked list, you have memory all over the heap. So that's that. After our ring buffer, what did we do? I think that's when we started our binary search tree. And this is our binary search tree, which we finished our basic implementation, and we're just playing with some more ideas on. But like basically, like I showed before, binary search tree looks like this. It doesn't have to be numbers, they just have to have ordinality, right? Like you have to be able to order them. And this is efficient. 100% safe rest win. Dude, this is all safe rest, Nightshade. It's all safe rest. So this is efficient when searching values, because you're essentially splitting your problem space into every time. So if you wanted to look for something that ended up being at the end of a long list of items, with a normal array, of course, you'd have to go all the way through the whole thing when you're doing value checks, when you're searching, right? Here, when we're searching, we know that if we're looking for 800, we know that it's going to be on the right side of 9. We know it's going to be on the right side of 17. We know it's going to be on the left side of 900. And so we're able to efficiently search through all these values. So hope that is a helpful overview, and explains some of the data structures that we've been using. AWR 417H, thanks for the follow. I really appreciate it. Suspect. It is pretty sus. You know, our binary search tree is safe. Okay. Yeah. There's unsafe Rust in this project, but you know, we don't need unsafe for a binary search tree. Yeah, I missed one chat there. Coder dyslexic. You're thinking about doing the 0D mastery class. I don't know that one. Or I'm going to do the Coursera Meta Front-End Developer Certification. Okay. Yeah, there's some costs involved. Yeah, totally. Yeah, I'm not, like, I don't know the best way at this point. You know, like, I went my own path. I was also, you know, like, older. I'm 38 now, and so that means I got my first job, programming job. Not my first job, dear God. My first programming job, you know, when I was in my late 20s. So I unfortunately and fortunately had many jobs before that. But yeah. Okay. Very cool. You're 38 too? Sweet. Yeah. Yeah, and you know, I mean, neurodivergence isn't a bad thing in programming. I mean, you know, there's a lot of, like, I consider dyslexia in the neurodivergent umbrella, along with like ADHD and autism and a few other things. So Nightshade, you're older than me, Nightshade? How did I not know this? I actually had somebody in chat that was 49 the other day, and I was like, wow, that's good. That's good. I'm usually like the oldest person around or close to the oldest, but you know, maybe I'm just hanging out with too many young streamers. Yeah, it's all good. Age is just a number, unless of course it's not. What else was I gonna say? Oh yeah, if you want to follow along, watch some of the older videos. They are on here on Twitch as VODs. You can also watch them on YouTube. Programming is an old man's game. Yeah, that's right. You can also watch them on YouTube in that playlist. And you can subscribe if you want updates on the YouTube channel. And if you want just like stream updates, or you like the whole Twitter thing, I'm occasionally on there. So there's the plugs. And again, you know, if you have any questions, please, I'm pretty interactive with chat, so please let me know. And if anything doesn't make sense, let me know. But yeah, welcome guys. It's great that you're here. Yeah, Ryan Winchester was in chat the other day. I guess it was on Dylan's stream, probably not. I don't think he follows me. Ryan, I don't know what you're doing. And he's a little bit older than me, so it's like, yes, a little bit. I don't really care though. It's not like it matters. Scott B. Hey, how's it going, Scott? How are you today? Thanks for dropping in. We had a node traversal working. I'm just now, like, I had it working where it was just going over and inserting all the items into a vec. And right now I'm just making it work more generically. Okay, there we go. So this would end up just being FN. And then this would be, whoops, F. Okay. So I haven't actually defined my function type because I forgot how to do it. Let's see how we do that. I forget how higher order functions work in Rust. Isn't that just absolutely ridiculous? Where do I have Rust by example? I feel like I have that up here somewhere. There it is. I feel like Rust by example would be a good resource for this. Functions. Higher order functions. Ha! Absolute win. Okay, let's try doing this. Yeah, you guys can mostly see it. These are functions that take one or more. Yeah, I know what a higher order function is. I'm just trying to read the code. I just forgot what I was doing, okay? I'm very confused. Oh, you're so dumb. Why would you do that to me? Why would you say, hey, this is higher order functions, and then you don't actually tell me how to define my own higher order function? Oh my god. That's really annoying. I just forget how function types work. Maybe it's in here. Nope. Okay. It's fine. Let's do the GPT thing. Okay, come on. There you are. How do I define a function type in Rust? I forgot. I forgot how. Functions are closures that can be called immutably without modifying captured variables. Okay. That's if you just need to read. Not really. Modifying captured variables. Pretty sure that's what I want. Okay, but no. How do you define a higher order function? I could just look at a fucking map implementation. I don't know why this is so annoying. Okay, where F function I32 to I32. Okay, that's all I wanted to see. That's all I needed. Was that so hard? Okay. So I believe what we're going to need is a function mute, since we actually need to mutate. And it takes a node, and I don't know if it returns anything. We'll just have it not return anything for now. I don't know if I have to declare that it returns unit or not. But let's just see if this works. It does not. Okay. Of course not. Oh, I have an unclosed delimiter. That's why it's not telling me what I need. Where? Oh, whoops. There we go. Trade objects must include the den keyword. Okay. I feel like you are wrong. Oh, maybe I can't. You know what? I actually think I actually think I have to declare this differently. I have to say this. We're getting there. Where f, I see why it doesn't work within that. And then that's there. And then let's just delete to the end. It'll be faster. Expected one of and found that. And that's because I just forgot an extra caret. Okay. This is fine. Cannot find type F in this scope. A trait with a similar name exists function? No. Did ChatGPT lie to me? What happens if I just return unit here? Does it fix anything? Nope. It does not. What if I do this? Does that fix? No. Oh, I'm being dumb. I'm being really dumb. I forgot to define it as a generic to my function here. That would be why I'm being done. That would be why. Okay. So now we have that. Isn't that classic? You can't even say I'm being dumb, right, Nightshade? Ugh, rough. It is funny how often, like in a work scenario, like I would try not to say like, oh, I'm being so dumb right now, or, you know, like all those kinds of things. And then like on Twitch, it's just like really common. Like almost every streamer is just like, I'm being stupid. Like even if they're like really, really smart, you know, like, I don't know, Tej is a good example. Maybe he's not really, really smart. I don't know. I hadn't, you know, who knows? But like, it's just funny. It's like, no, I'm stupid. I'm stupid. You know, it's just like a classic Twitch life coding thing. I've started to say it more at work now, and I think that's a problem. I think it's probably not a good idea. Exactly. Huh. Not sure why that happened. Interesting. You know. Silent Z, thank you for the follow. Welcome. Thanks for hanging out. Okay, so now at this point, we are not passing what we want here. So essentially this node traversal would consume, and I'm just not sure exactly what I want to do yet. Like, am I okay with it consuming, or am I not okay with it? I think the point of this was that I wouldn't I wouldn't consume it. Oh, 1 second. Let's just consume it for now. We'll just pretend like we can consume everything. We're gonna consume everything. It's not scary, right? Okay. So instead of as ref, we're gonna do a take, and that gives us ownership over this here. I like it. I like it. And then we're gonna do the same thing here. So why are you saying this? Oh, it's just because I didn't pass what I actually wanted here. Okay. So this will be good. Okay, we're gonna have to fix several things about this, but that's okay. That's why we're here, to fix things. We're gonna take the actual BST, we're gonna create a vec new, it's mutable. Instead of the reference to bst.root, we're gonna take bst.root. Okay. And that gives us a box node T. And then here we have an N, and we're gonna say v.push n.value. Okay. Let's see what it hates about this. So far, nothing, but that's because I have a type error in IO traversal because I'm passing a reference to a BST instead of the BST itself. So let's get that taken care of. And let's see what else we have a problem with. There must be a problem up there because I know that this won't work because this is consuming and this is also consuming. So obviously we have a problem up. Okay. Oh, it's right here. And then we should have consuming issues. Nice. Love it. Okay, so what do we want to do? I can't remember if I derive clone or not, if T is clone. I could do that. It's a good idea anyway. So we can just derive clone. I think it will work. I think it works. I think it will work. Okay. Looks okay so far. And now we can just clone our BST here. Okay. Let's see if our test works. No. It definitely doesn't. Okay. Function IO traversal BST. Oh, it's because I didn't say BST is mutable, but it absolutely It absolutely is. Because otherwise I can't take. Yeah. Okay. Hold on. And then I also need to declare n is mutable. Otherwise I can't take from n, which is reasonable. And now we have all the mutability for all the reasons. Okay, let's see what's next. F, you what? Okay, let's do a build so we can actually see the full compiler output. N has type box, which does not implement the copy trait. Value moved here. Oh, yeah. No, this is very true. Ooh, yeah, how do we want to do this? We would have to... How do we want to do this? So I can't do all of these things within, but I also can't. That's what I have to do. It's ugly, but it's fine. I just have to take right before I move in. Let me just think if there's something nicer I want to do. Is something going right today? You know, it's actually going pretty well, Gio. How's your day going? I was starting on an iterator and it just got really complicated, surprisingly. And I was like, okay, let me just get like an in order traversal working. And so I got an in order traversal working, pushing everything to a vec. And I was like, okay, this is cool, but I should make this generic. And I was like, I haven't really like messed with a bunch of higher order functions in this way before. So I should probably practice that. And that's where we're at. Yeah. So hope you're doing well. So we'll just take n.write right here. And then obviously we could do something nicer here, but we'll just start with this while I'm trying to get this to work. Cannot borrow f as mutable as it is not declared as mutable. Cannot borrow as mutable. Borrow of moved value f. Interesting. So if I have a function, yeah, I just need to make it mute. If I have a function, but I'm trying to process it, I understand that I could just make it mute. So because I have a function mute, like if it was just a normal function, would I also have to do that? I guess that's my question. It's only going to make me do that on a function mute. Of course, now I have other errors. Borrow of move. Well, value borrowed here after move. I did not think about. Right, yeah, I know the difference. Thanks. I didn't think about that functions. Like functions are values. This whole borrow checking on functions is very weird to me right now. Because it's a function. But I know it's a value. But again, it's my first time playing with it. So okay. So I know I need it to be function mute because otherwise I can't do what I want with it. So, oh wait, I have to, it's the wrong way, right? I want to do this. No, that was fine. Yeah, that's fine. Okay, now what? Now it's probably the borrow checker problem. Let's build it over here. Move occurs because f has type f, which does not implement the copy trait. Value moved here, value borrowed here after move. That is the weirdest thing to me, but okay. Okay. Yeah, that's what I'm wondering. You do and mute f for this issue? Like f and mute f, yeah. Because then I have to do here. Ooh, this is not like really obvious to me how that works. Because the idea that like I have to pass the function as a mutable reference is just strange to me. Okay. So yeah, now it's not happy with my closure. Let's see if the compiler tells me how to fix it or not. Oh, it just isn't sure what the type of n is? Okay. Type must be known at this point. Okay. That's fine. That's not hard. Now, it is a box node T. Now what I'm thinking though is that I can probably get rid of the box part of that, but we'll find out. Box node T. Okay, you don't like my type? Yeah, it's a downside of this approach, and you'll need to pass a and mute closure. Okay, right. Okay, give me a second. Hey, what's up? Yeah, I don't know. I can't think of anything that I want. You can send me a list and I'll go over it. You wanna show me? Okay, hold on.
This is the list?
That's the list? Yeah, that's insane. Yeah, I don't know.
There's like, I don't know what this is. Like,
Yeah, I don't know what that is either.
and like these.
Mm-hmm.
I don't know. Haven't we had these?
I mean, I would take some of the nut butter packets.
packets? Okay.
Just like some, not like tons.
What? Right, because we have peanut butter, almond butter, honey, and cashew, and the chocolate hazelnut and almond.
Ooh, chocolate hazelnut and almond.
Okay. Do you want like a box?
Yeah, sure.
That-
Oh, yeah, we can get a box. That's fine.
Okay. Okay.
All right. Sounds good.
Anything else?
I think I'm good right now.
Okay. That's too bad. I mean, thanks for
Mm-hmm. All right. Love you.
Bye, I love you.
Getting snacks. It's going well. Oh, right. This is when I need to pass the whole and mute thing over here. So I both have to specify my type. And now that the type checker is done, we all know what's next. It's the borrowed checker. Well, I guess it's still type, but yeah. Okay. Kind of. Right. Okay. Well, it seems to like this. Let's see what happens with our tests. Sweet. Okay. Yay, higher order traversal done. Okay. Cool. So now we just need to fix a couple things. So right now we're, saying my IO traversal is still basically my Vec, my Into Vec, and I could change it to not be. Or I should change it to not be, is what I should say. So let's do that next. So let's see. For now, let's just yank this. And we'll go down to our from here and paste it. And we'll go here and people who actually know Rust, like, is it bad that I like to rename this? Like they, from says value, and like, is it non-idiomatic for me to rename it to like what it actually is? I don't know. Oh, Koovie Man, hey, thanks for coming in. I didn't actually, what's funny is Geo was giving me those the messages, and I didn't notice that it switched, like that it wasn't Geo still giving me the tips. So yeah, the and mute F thing, that's helpful. Thanks. Welcome in. Yeah, cool. Okay, so here is our from BST for Vec. I still need to change this to IO traversal. And the only... Oh, right. I shouldn't have yanked that whole thing. It didn't exactly make sense. Because I'm actually just going to do IO traversal here. And then pass in my BST. And then this is just going to say what I'm going to do with my node. And that looks good. Okay. So then the next step is I'm going to go here. We defined our function. We're there. That looks okay. Yeah, that's exactly what I was asking, Kuberman. Thanks. Yeah. I don't know, like, because it was the same thing here. It was like from value vec, and I was like, well, that feels weird to then call it value down here, especially when I did like a 4v in value. I don't know, it just felt weird. So yeah, thanks for chiming in there. That's helpful. Okay, so now we just need to change IO traversal to actually take our mutable function, which means I basically just have to copy this whole stupid thing. And yeah, that's fine. Well, almost fine. I always do it one character off. Well, the whole paste kind of sucked. That's really what that came down to. Okay, so then this is our opening bracket. This is correct, and we need a comma. Sick. Okay, IO traversal takes the right type, but this is all wrong. It should be if let sum and bst.root.take node traversal and pass that through, and we don't return anything. Whoops. Okay. Now why are you mad at me? Oh, because I still have this. Silly me. Now it's just NF. I inserted an extra space. Oh, and F is missing in generics. Yeah, you're absolutely right. I missed that one a lot. Okay. Takes an and mute F. That looks fine. Okay. It's just down here where it doesn't work. And that's fine because I actually don't care about this test right now. That was just my original. And I just care about this one. Boom. Hey, that's pretty sick. I actually like that. That's not bad. I'm pretty happy about that. It's pretty nice. So now my from just has this basic thing. Yeah, that's not bad. I'm sure there's something like smarter I could do somewhere, but I'm pretty happy with that. I mean, you know, this iterator's kind of in the way. Let's just maybe we should move our iterator down so that it's out of my way. What is it, 15? Okay. Okay. There we go. Now we can kind of see it a little bit better. Node traversal, IO traversal. I mean, I said it's in order traversal, in case anybody's wondering. But, I mean, why would you do any other traversal on a binary search tree? I don't really know. Now, I mean, other traversal ordering makes sense for a non-binary search tree, like a just normal binary tree or other types of trees, but it'd be kind of weird to do. I mean, maybe there's a use case for it that I don't know about, but it'd be kind of weird. I guess if you wanted to traverse, and let me think about this. If you wanted to create a Like, why would you do this? But if you wanted to create the same tree by value, then maybe you would want a pre-order traversal. Yeah. If you wanted, yeah, that's right. Yeah. If you wanted to like go through your whole binary search tree, right? And kind of like duplicate it in a by traversing it, you could do that with a pre-order traversal. I guess that's when you wouldn't want an in-order traversal on a binary search tree. But I don't think I'm going to do that right now. It's not like it's hard. I mean, what's cool about this structure, of course, is like in order to like this could be cleaned up. I'm aware of that. I just made it work. But all we have to do is change where f of n is called in these three operations between pre-order, in-order, and post-order. So in pre-order, f of n would go up above our left, and post-order, f of n would go below our right. In the middle just means we have in order. So pretty cool. I'm pretty happy with that. It's almost in 3 hours. I think I'm good. I could use a little break. Thanks so much for hanging out. Thanks for joining and chatting and pointing out silly things and helping me figure out this. I actually had not messed with higher order functions before this stream in any meaningful way, and so there was some learnings to be had. I'm sorry, creating my own higher order functions. I've used higher order functions, of course, but creating my own. So yeah, sweet. Cool. Let's see. What's next for our binary search tree? I think what's next is actually doing our iterator, if I'm up for it. I mean, the thing is, like, iterating over my binary search tree. I could just create a vec out of it. Like, we already have that functionality as like a user of this data structure. I could say, if you want to iterate over this, create a vec out of it. But I think it's probably better to not say that, and to maybe like it would help me. I would learn things by implementing an actual iterator for a complex type like this. I don't think it's gonna be fun, but I would learn something. This was my naive attempt earlier, and then I decided to just do in-order traversal because it's easier, and it's kind of like a sub problem of processing how we want to do the iterator. But yeah, so anyway, thanks for hanging out, and let's see who's around for the rating. Let's see, any obvious ones? Anyone obvious that I haven't rated in a while? Not really. Let's... Another Emacs dev? Hey, Silicon Milk. Yeah, that's right. Gotta find somebody else that's doing Emacs, right? Oh, man. It's good times. I will look. We can do that. There's probably no one else doing Rust. All two of them? Emacs is life. Man. This is it's not a bad operating system, Emacs. It's not the worst I've ever used. All right, let's see what Twitch recommends for us. Let's do a little refresh. See some waifu action on the homepage usually. Oh, nope, not today. Okay, I don't care about this. Let's see. Is anybody actually? Emacs, why aren't the tags loading? What the hell? Fiber internet, everyone. Fiber. Oh my god, I can't load tags. You gotta be kidding me. Unbelievable. Okay, let's try a refresh. Second refresh. See if tags will load at this point. Search tags. Emacs. It literally doesn't understand. Okay, there it is. Oh, okay. Oh, this is awesome. Okay. Look at where Emacs led us. It led us to Haskell. All right, let me just make sure this guy's not spouting insanities. Seems fine. Seems fine. I don't hear anything. But that's fine. We'll do it. All right, guys. Oh, he's talking finally. It says English. It says Haskell. That's good enough for me. Kinran, huh? Thanks so much for hanging out. If you don't already follow the stream, send me a follow. I would appreciate it. And you know, there's the YouTube stuff. You know all the places. I don't need to tell you guys. All right, I'll catch you over on the next stream.